Hello there, welcome back to our channel. And this time we are going to talk about equivalent model of a BJT that is shown on your screen. And our job is to find an input resistance of this model. Before I explain to you how to find that, I want to let you understand what this model is about. So you see, this is the BJT model, which is having the 3-pin device, that is the base. Here is your collector pin, and here is your emitter pin. And from base to emitter, you have an input resistance R pi, that is the resistance between base and emitter pin of the BJT, and value of it is given by an input voltage VBE divided by an input current IB. Note that you have an input voltage VBE that gets developed across this base emitter junction of the transistor. Now, when you want to use it as a small signal amplifier, you basically use this current dependent current source, whose value is beta times the input current IB. And this is essentially a current that is flowing from the collector pin of the BJT, and that is how it flows. Finally, you have an emitter resistance, which is also called as emitter degeneration resistance, and the current through this resistor is an emitter current IE, which is the sum of the two input currents and the output currents. The input current is IB and the output current is IC. So IB plus beta times IB, which is IC, is equal to the current through RE. And here, from collector to the ground, you have an output load across which you want to develop an output voltage. So in the red, you basically have this an equivalent model of a BJT representing a specialized circuit. So what is that circuit? Can we draw and obtain that circuit? Yes. So as I said, you have this BJT, which has a 3 terminals or 3 pins called as collector, emitter, and the base. And I just said that this is an internal resistance between base and emitter pin, or between base and emitter input junction, that is there. And then from the emitter to the ground, you have, this is a ground terminal. So you can draw RE, and you say that this is your resistance RE. From collector to the ground, you basically have a resistance RL, and here usually you have V plus. So when you draw the small signal model of this circuit, and the small signal model is right here. So when you draw a small signal model from the circuit, you basically short circuit all the voltage sources. The DC voltage sources are short circuited in the circuit, and if there are current source, then they are open circuited. So what you do is, this will be connected to the ground, and therefore in the model you see the RL is connected between pin collector pin and the ground, and that's how this RL, one end of the RL is connected to the ground. Okay. Now you can say that I want to apply an input signal to this circuit, that is, let's say, V in right here, and that's it. So you have this collector base current, the base current, and right here you have an emitter current. So basically, this is a model for this circuit. Okay, so this is essentially, you have like, you can take the output from the collector. If you say this is my output, so essentially you say that this is output right here. Okay, now the question is how to derive an input resistance or input resistance of this circuit, which is basically the ratio of voltage divided by the current. So for that, you draw the small signal model as shown right here. And then in the blue, you see I have connected a voltage source that is called as test voltage. This is a test voltage, right? So you basically remove this small signal AC signal, external signal that is to be applied for amplification. Rather, you apply the test voltage, and because of that, across the base with respect to ground, okay, and then because of that, your current is flows into the circuit, and the ratio of this test voltage divided by the current is going to be your R in. Okay, so R in has to be find out. So we have to know what is is. So we basically can apply a Kirchhoff's voltage law into this loop to obtain the Vs over Is. So as I said, the current here is your Ib, which is basically your Is, and this is the current is your Ic, and here the current that is coming here is Ib plus Ic. Okay, and we will write that equation. So applying KVL, Vs is equal to Ib times R pi. This is the voltage drop. That is the product of current and voltage is the voltage VB. And then you need to obtain the voltage drop here, which is the sum of IE times RE. That's it. So simplify that. This will be IB into R pi plus you can write IB is your IB plus beta times IB, which is the base current plus collector current multiplied by RE. And therefore, we see that. So you further simplify it, it would be IB R pi, take the IB out, and this will be 1 plus beta IB times RE. And then you again take the IB out, it will be IB out, which is R pi plus 1 plus beta times RE. And that's your Vs equal to this. Now we know that your IB is nothing but your Is actually. You see this right here. And then plug that value. So it will be Vs divided by Is, which is basically this expression. We will put this value into this equation. Instead of IB, we are using Is, and that is nothing but R pi plus 1 plus beta times RE. So that's your expression for the voltage source, for the input resistance actually. So this is how you can successfully find an input resistance of the circuit. If you want to find an output resistance of the circuit, I leave it as an exercise for you. So for the output resistance calculation, what you need to do is remove the RL and apply a test voltage Vs again to the collector pin right here with respect to ground, and then calculate RO would be Vs divided by IO. So you essentially find an output current. We can do that in a moment. So you basically apply a KVL into this loop again to find an output current of the circuit. So hope you understood this video, and if you did so, share it with others.